said, I've been working as a knowledge gatherer for LIVE for the past year, where I've been focusing on really just the geology and geoheritage of the Iveragh Peninsula. So in this presentation, I'll run through some of the geologic background and geologic history of Iveragh, as well as highlighting some of the ways that this geology can be incorporated into the geography curriculum, both as examples in the classroom and in the field. So what we're really trying to do is promote the geology of Iveragh and promote the area of an outdoor classroom for schools in Iveragh as well as further afield. We are really keen to have any input or feedback or ideas from any teachers as well, and to find out if there's any specific information that we can provide for you. So at the beginning, I'll go through the geologic story and some of the resources we've already created, and then following this, we've left a bit of time to get any ideas or input that you might have. So while the geology in every part of Ireland is unique and interesting, the geology of Iveragh is particularly special. Iveragh has a long geologic history going back over 385 million years, and through this time, the area has travelled from the southern to the northern hemisphere. It's been covered by deserts, caught up in continental collisions, and buried by ice. And each of these different events have left a really distinct signature on the landscape for Iveragh. And the landscape also contains a really excellent range of geological and geographical features and processes that really make it an excellent place for carrying out fieldwork. So I suppose apart from being an integral part of the curriculum, fieldwork is something that can be really enjoyable, and students can also pick up a lot of really valuable skills like observation, group work, data collection and surveying, which are really important if they want to continue in the geoscience field. And the other thing is that Iveragh is of both national and international geologic significance due to the presence of the world famous and some of the oldest tetrapod trackways in the world, as well as being in the vicinity of McGillycuddy Reeks, so the tallest mountains, and then having this really nice recently glaciated landscape. So for the next few slides, I'll run through the geologic story and the major events that have shaped the landscape of Iveragh. When we talk about the geologic history of Iveragh, we generally break it down into 4 major periods. So they are the Devonian, the Merviscan orogeny, or the mountain building, the Ice Age, and then the modern geological processes. So the story of Iveragh really begins about 385 million years ago during the Devonian period. And it's during this stage that all the rocks around Iveragh would have been deposited. So these are predominantly sedimentary rocks like mudstones, sandstones, and conglomerates, and they're part of that larger old red sandstone formation. So during the Devonian, Ireland wasn't an island like it is today, but existed as part of a much larger continent known as Laurussia. And this Laurussian continent would have straddled the equator, and within this continent, Ireland would have been located to the south of the equator, so about 15 to 20 degrees south of the equator. And because it was close to the equator, the climate would have been a lot hotter and drier than it is today, and Ireland would have been dominated by this vast, barren desert landscape. We got someone else coming in. So within this barren desert landscape, the area around Iveragh was actually subject to pretty frequent flash flooding events, and that were fed by these periods of really heavy rainfall. So during these periods of heavy rainfall, we would have had floods flowing across the landscape, as well as the development of lots of rivers and channels and streams. And at the time, Iveragh, as well as much of the surrounding area, was part of this big low-lying depression or basin of land known as the Munster Basin. And this was an extensional basin, so it formed from the pulling apart and extension of the Earth's crust, and subsidence and sinking within this basin was accommodated by the development of geologic faults, which allowed blocks of rocks to move relative to each other. So this low-lying area of the Munster Basin acted as the natural drainage point for all these rivers and floods that would have been transporting sediment across the area, and all the sediment was eventually deposited and it accumulated within this basin. So it's estimated that somewhere around 6 to 7 kilometers of sediment would have accumulated within the Munster Basin, which is quite a lot. So eventually it would have been compressed and consolidated and liquefied into those solid old red sandstones that we can see across really the entire peninsula today. However, sedimentary rocks were not the only rocks forming at the time. As the Munster Basin was forming with the extension of the Earth's crust, the faults and fractures that were developing also provided routes for magma from deep within the Earth to rise towards the surface. So some of this magma would have remained below the surface, where it would have formed intrusive igneous rocks, but in other areas it actually did break the surface at those more violent volcanic eruptions, and we would have had the formation of extrusive igneous rocks. So in terms of volume, igneous rocks are quite minor across the peninsula, but they do tell an interesting and important part of the overall geologic story. So the biggest area of volcanic rocks we have is centered around Begonish Island, and these are dolerite, and they formed as a sill. So dolerite is essentially just the coarse-grained equivalent of basalt, so it has the same chemical composition, but it just has a different name due to the different crystal sizes. And these bigger crystal sizes are due to the fact that it would have cooled more slowly below the surface. But in some areas, we did have this magma breaking to the surface, and this can be seen really clearly at Whitestrand over the water near Castlevine. And what happened here was that as the magma broke to the surface, it came into contact with and mixed with the sands and silts and mudstones that would have covered that floodplain environment, as well as ash and volcanic fragments that would have been produced by the eruption. So this resulted in the creation of this really colourful and jumbled rock mass made of all these different fragments known as a volcanic breccia. The final type of igneous rock we have across the peninsula is tuff, and tuff is a rock that's predominantly composed of ash. So it consists of about 75% ash, and it would have formed from the ash that would have been created during big volcanic eruptions falling to the ground where it hardened and solidified. So these tuff deposits can be found around Valencia, as well as by St. Finian's Bay. And these ash deposits really provide evidence of a much more violent period in Iver's past, where we would have had these big volcanic eruptions happening nearby that were capable of creating these huge columns of ash and gas. So throughout the Devonian, the continents had been gradually drifting towards each other until eventually about 300 million years ago, there was a big continental collision with the three continents at the time. So Russia, that was carrying Ireland, Gondwana and Siberia all collided to form this giant supercontinent known as Pangaea. So during this continental collision, the Iveragh Peninsula got caught up in a mountain building event that had a really profound impact on the landscape. So as the plates were pushing towards each other, the Devonian old red sandstones were compressed and squeezed, and the once flat-lying rock layers were crumpled and buckled and pushed upwards to form a vast mountain range. So it was during this time that we would have had the formation of the McGillicuddy Reeks and the Dunkerin Mountains, as well as the establishment of that overall ridge and valley landscape of Iveragh. So we refer to this mountain building event as the Variscan orogeny, and in Ireland it would have been occurring at its maximum extent somewhere between about 320 to 290 million years ago. And the other thing that we had during this mountain building event and continental collision is that during the folding and buckling and development of tectonic cleavage through the rock, we also would have had a shortening of the former Munster Basin area to about 50% of its original extent. So by the Quaternary, our present geologic period, which began about 2.6 million years ago, Ireland would have completed its northward drift and would have obtained its present geographic position. And around this time, the global climate would have also begun to oscillate between these periods of cold and warm, known as glacial and interglacial periods. So during the glacial period, we had great ice sheets building up across Ireland and much of the northern hemisphere. So Ireland has been glaciated on a number of occasions, but most of the features and deposits that we would see across Iveragh would come from that most recent glacial period, which would have been at its maximum extent about 25,000 years ago. So during this last glacial period, much of the southwest of Ireland would have been covered by this big ice sheet referred to as the Kerry-Cork ice cap, which would have spread outwards from an ice dispersal centre located around Kenmare. So this ice sheet would have covered the entirety of Iveragh, with only really the taller mountains sticking up above the surface. And this ice would have moved and advanced across the peninsula in a dominantly southwesterly direction towards the Atlantic, but there also would have been quite a significant component of northward flow into what's now Dingle Bay. And as the ice moved across the landscape, it also would have been fed by smaller local glaciers that were forming in the mountains across Iveragh. So these glaciations and the ice ages really put the finishing touches on the landscape of Iveragh and left behind this distinctly ice sculpted and shaped terrain that we see today. So as the ice sheets were moving across the landscape, they had a pretty huge capacity for erosion. So they would have been carving out valleys and corries and smoothing and abrading rock in the lowlands to create rock-smooth terrain. But it wasn't just erosion that was happening. As the ice sheets were traveling, they were also picking up and transporting a lot of rock debris and material, which eventually, as deglaciation began and the ice sheets began to retreat, this could no longer be transported. So it was all deposited and dropped to the ground as the big extensive deposits of glacial till and moraine that we have across the lowland of Iveragh. The other thing that would have been happening is that as these ice sheets were melting, obviously we had these vast quantities of meltwater being produced. And because so much seawater had been locked up in ice sheets globally, this actually resulted in a pretty rapid rise in sea level. And it was during the sea level rise that the coastline of Iveragh that we were familiar with today would have really begun to take shape. So as these ice sheets were melting and the water was draining across the landscape, in certain areas it would have been blocked and dammed by depressions that were created by both glacial erosion and deposition to create a series of lakes, many of which we can still see around the peninsula today. But for the most part, this water really would have drained back into the ocean. And during this, we would have had that sea level rise that isolated many of the islands of Iveragh from the mainland, as those lower lying regions that had formerly connected them to the mainland would have been flooded. We also would have had the drowning of the Dingle Peninsula and the Dingle Bay and Kenmare River, and it was at this stage that Iveragh, the peninsula, really became established. So the formation of Iver's geology is definitely far from over, and there's a lot of geological processes that we can see in action today. We have processes like rivers flowing across the landscape and landsliding and mass movement, but I suppose nowhere is this constant evolution of the landscape more visible than along the coastline. So the main shaping force of the coastline of Iveragh is really the action of the waves and the power of the ocean. So the erosive power of the waves has created pretty dramatic coastal scenery with cliffs and caves and sea stacks and sea arches. But it's not just erosion that's been shaping the coastline. There's also been quite a considerable amount of deposition with formation of sandy beaches and the more pebbly storm beaches, as well as longer sand spits and tambolos and things like that. So while these features do appear quite permanent and unmoving in our landscape, it is important to remember that they are really only temporary forms that are constantly evolving and being reshaped and remolded as this process of erosion and deposition continues. So to wrap up that geologic story, I'll quickly link into the key lessons or topics that can be tied in with each period. So during the Devonian, we have the opportunity to introduce the rock cycle and the process of rock formation, with particular emphasis on sedimentary rocks. And we have that really nice example of that floodplain or desert environment as a sedimentary setting. We also have Valentia Slate on Valentia Island, which is a really nice case study of a quarry and human interaction with the rock cycle. And then finally, we have more of that focus on volcanic processes and igneous rock formation. With the mountain building, we have an introduction to earth structure, as well as the concept of plate tectonics and destructive plate boundaries, and also those processes of folding, faulting, and mountain building. With the glaciations, there's an opportunity to explore and examine the Pleistocene glaciations and the signature they left in the landscape, as well as more generally the glacial processes, patterns, and the landforms we get. And then if you look a bit more closely and a bit more detail into that post-glacial sea level rise, there's also a bit of an opportunity to begin explaining the difference between isostatic and eustatic sea level changes. So finally, with coastal geology, I guess the major thing is, again, the processes, patterns, and landforms that will be associated with sea erosion, transport, and deposition. And we also have the opportunity to talk a bit about how waves form and the power of waves themselves. So to date, we've been working on putting together a series of resources that, while not directly designed as educational materials, could be useful resources for incorporating local examples or as suggesting sites for fieldwork. So these resources include a series of geotrails and more general trails, I suppose, that provide self-guided tours through some of the most interesting geological regions of the peninsula. So depending on the trail, these either provide a bit of a glimpse into an aspect of the geologic history of the area, or else they can provide more in-depth information on specific geological features. So these are really been designed to promote a general understanding and appreciation of the earth sciences by having a bit more interactive, hands-on engagement with the landscape itself. But really, any of these trails cross landscapes that include a range of geological features that would be really closely linked into the geography curriculum. The other thing we have is I've developed a number of regional geosite maps. These provide slightly more general information than the geotrails. And as you can see here, our study area has been divided into 3 major regions. So each of these regions contains sites that extend the entirety of the geologic history. So from the early deposition of the rocks through to those later processes of ongoing coastal erosion and deposition. And these maps explain various aspects of the landscape, such as how the cliffs form, what rock layers can tell us, and how we know the area is once covered by glacial ice. And the other thing we have is a number of more general resources. So we have some resources on the coastal geology of Iveragh, highlighting the various features that can be seen across the peninsula and where they're found, and then more general resources on that overall geologic history. So some of these resources are actually available on our website at the moment, so you can look at them there, and the remaining ones will be up in the next couple of weeks, I would imagine. So another thing that I did is that I have drafted up a field guide to the geology of Iveragh aimed at secondary school students. So this has focused quite closely with the geography curriculum, and I've tried to link into topics such as rock classification, geological time, geological principles, the story of Iveragh through geological time, and then more local site-specific information. So I also created a series of field activities along with this, and these are really focused on identifying and interpreting rocks and features in the field, creating geological sketches and some simple mapping exercises. So since incorporating local examples and references, as well as carrying out fieldwork, is really recommended, hopefully these will serve as a useful guide or information source for bringing more of that local story into the information that we would already be covering in the classroom. It's definitely not a finished resource at this stage, and the majority of the site-specific information and those field activities have been centered around Valencia Island. So I guess depending on the level of interest, or if you guys think there's the potential to develop this a bit further, we could include more sites. And I guess this could be really useful for the geographical investigation component of the Leaving Cert. And it's also something that could be done as an activity with transition year students. So the final thing I'll mention is something that we have considered providing for primary schools, but I thought I'd put it out here to see if there might be any interest at secondary level too. And this is the provision of rock samples of the local geology that could be provided for schools and then examined and interpreted in the classroom. So these rock samples can be accompanied with a little booklet identifying the various rocks, describing the characteristics and explaining how they're formed. And then students can begin to distinguish between the local geology and really practice recording their observations on the physical characteristics, and in the process gain some really valuable practical hands-on experience in actually identifying and interpreting real rock samples. Having these rock samples might also help to bring the geological story to life a bit more, and also get students to start making the connections between how various rocks form and the actual physical characteristics we can see in the rocks themselves, as well as how various rocks are related to each other. So I will finish up there and open it up for any questions or thoughts that you might have. I guess things we'd be really interested about hearing from you would be what information would be most useful for you. Is there any specific information we could provide? What resources might already be available to you? And would there be any interest in that field guide or having rock sample kits? So thank you all very much for listening, and I really appreciate you all attending, and really any information that you can provide us with will be a really great help for us at this stage. So thank you.